Hi folks, we are back after a long time with a new video. We were actually doing a chapter on differentiation, so we'll be continuing with that. In the last time we were doing things related to maxima, minima. We'll continue with that. We are now in the question number 5, question number 3 of this exercise 6.5, question number 3. So that's what we'll be doing. I just read out the question. Find the local maxima and local minima. If any, for the following functions, find also the local maximum and local minimum values as the case may be. So we not only have to decide whether there is a local maxima and minima, first we have to decide and find out what is a local maxima minima, and apart from that, in cases where it does exist, we will find out what is the local maxima or the local minima value. So that's how it is going to be. There's a format in which we do it. So we'll follow the same format and we'll try to get the local maxima minima value. To start with, the very first function is f of x equal to x squared. So let's see what we're going to do there. This is exercise question number 3, sub question 1, f of x equal to x squared. So f of x equal to x squared, always for local maxima minima, the tailor-made format is that we will do, we'll find out the first derivative, we'll find out the second derivative, keep it ready, then go for the critical point and then decide whether it's maxima or minima. So that's how the step is going to be. So we'll at this instant itself we'll try to get the first derivative for x squared. X raised to n, we know the derivative is n x raised to n minus 1, so that way this derivative is going to be 2x, and then the second derivative, when we take it, it will come to 2 because it is 2 times x. So like that you have got both the derivatives. So now it is to find the critical point. So to find the critical point, we will write let f dash x be equal to 0. So then in that case, let's see how that goes. F dash x for us is 2x. So 2x equal to 0, which means that x is 0. It's as though the 2 is multiplication, goes on the other side, becomes division, and you get x as 0. So getting x as 0. So x equal to 0 is your critical point. When you visualize it in terms of graph, it could be like this, like at x equal to 0, maybe it could be a hill like that, or it could be a valley like that. It could be any one. That's the meaning of critical point. At the critical point, you could have in our normal English hill, or you could have a valley. That means depending, it could be a maxima or it could be a minima point. So that's the significance of this x equal to 0. Having got this x equal to 0, we will check whether it's a maxima or minima. So how we check the maxima minima is you take the second derivative and substitute. So we will find out f double dash at 0, second derivative at 0. You know that f dash at x is 2 for any value of x. No matter whatever value of x you put, it is 2. So in particular at 0 also it is 2, which is positive. So if you get the second derivative as positive, then that is a minima point. That's how we conclude. So therefore x equal to 0 is a point of minima. That means you have it going down like that. And then they say that first find out local maxima minima, and then what is the local maxima minima value. So therefore the local minima value will be, therefore f at 0 is x squared. So that is 0 squared, which is 0. So therefore the local minima value is 0. So that is what the problem is expecting. So it's a tailor-made pattern where you find the function, find its first and second derivative, get the critical point, and after getting the critical point, at the second derivative, decide whether it is positive or negative. If it's positive, it's going to be a minima point. If it's negative, it is going to be a maxima point. That's how it is. It should be okay by this, but we'll do one more problem so it will become like fixed as to how it is. Second question is x cube minus 3x. So let's see that. The second sub question, it says that it is x cube minus 3x. Yeah, same way as we did before, we'll take the second derivative, first derivative and second derivative, go for the critical point and then check the second derivative, how does it behave. So let's get the first derivative. The first derivative is going to be 3x squared minus 3. How about the second derivative? The second derivative is going to be 6x. So that's our first derivative and second derivative. Now let's go in for our critical point. Let g dash x be equal to 0, which means it is 3x squared minus 3, which is equal to 0. You can factor it the way you want. Okay, there are many ways of factoring. Maybe we can write it like 3 times x squared minus 1 equal to 0. Then 3 is multiplication, it can go on the other side, it will become division, and that way you will get x squared minus 1 as 0. This can be written as x squared minus 1 is of the type a squared minus b squared. So you can factorize it as a minus b into a plus b. So writing x squared minus 1 is as good as writing x minus 1 times x plus 1. And then each of them is 0. So when x minus 1 is 0 and x plus 1 is 0, then in that case x can be 1 and x can be minus 1 also. So there are two values for x. Therefore the values of x are plus 1 and minus 1. These are the two values of x. Now what are these two values? These two values are the critical points. So we have to then decide. Now you have got the critical points, and we have to now decide whether which one is a maxima point and which one is a minima point. That's going to be our next step. So what we are going to do is we are going to take the second derivative. It's always the second derivative that decides a maxima or minima point. So let's take the second derivative. We'll say that therefore g second derivative of, let's just write it once again, it is 6x. So we'll decide what happens at 1. At 1 it is 6 times 1, which is 6, which is positive, which means that x equal to 1 is the point of, because it's positive, it is point of minima. And so also if you look at minus 1, then it is 6 times minus 1 minus 6, which is less than 0. So x equal to minus 1 is the point of maxima, because you have lesser value, point of maxima. So that's clear to us, which is the point of maxima and which is the point of minima. Now that's not all. They ask us to find out the maxima and minima value. So let's find that. Therefore, where we will try and find out g at 1. What is g at 1 that we will get? We'll get 1 cube minus 3 times 1. We'll substitute in this. So we will get it as 1 minus 3 minus 2, and g at minus 1. When we substitute, it is minus 1 raised to 3, 3 times minus 1. So that's minus 1 plus 3, which is 2. So your maxima and minima values are minus 2, negative 2 and 2. These are the values. So yeah, that's how it goes. So the local maxima value is 2 and local minima value is negative 2. So that's how we go about it. It's quite simple and very easy to do. So that's how we carry on the work. So that's all for this video. Now in the next video we'll come with more problems. You have this question with say 4 or 5 sub questions. So one by one we'll take the sub question and we'll finish. That's all for this video. We'll meet you soon with the next video. Thank you.